Okay, I want to remind you of a problem we did last Friday. Everybody was here, so it should look familiar. Write an equation of a line parallel to y equals 5x minus 2. Now, if you have to write an equation, they talk about the word parallel. You need to wall your y, and if y is by itself, you make your MB label. Now, in parallel, this is my M, but I want to find a different B. So y equals blank x plus blank. Your M is 5, and then your B you use to, again, you need to find a different B than the minus 2. The minus 2 doesn't mean anything. Y equals M dot x plus B. And my M is 5. Then 4 is going to replace my y, and negative 3 is going to replace my x. So I have 4. 5 times negative 3 is negative 15. Now don't forget to add your 1b, because you have to figure the b out. So negative 15, you need to add 15. 4 plus 15 is 19. You got 1 dot b. Okay? 19 divided by 1 is 19. Okay? And there's your parallel equation. These two lines are parallel when graphed. Okay, now you're going to learn about, first off, watch me. You can write this down if you want or just observe it. Today we're going to be talking about two lines that do cross. They're not parallel, but when they cross, they form a 90-degree angle. Okay? So they're going to cross, so the slopes won't be the same. They form a 90-degree angle. Now let's talk about two such lines. Wall to y, M and B it. So B plus 4. And then from there I go down 1, forward 2. Okay, then I take the ruler, make my line. Okay, then in my other equation, I can MB that. We need our M to be a fraction. So B minus 2, so 1, 2, and then up 2 over 1, okay? Now, these two lines I made, they cross, and they cross at a 90-degree angle, okay? The reason why, so they're called perpendicular, okay? Perpendicular. Parallel is they never cross. Perpendicular they do cross, but they cross at a 90-degree angle. Now here's why. Look at the slopes now. They're not the same. First off, one is negative, one is positive. That always happens on perpendicular lines. Negative and a positive. And also, they're just flipped, upside down. 1, 2, 2, 1. Negative, positive. Okay, these will be perpendicular as well, okay? Because one of them positive, one of them's negative, and they flip. They're called reciprocals. So minus 1. Then I go up 2, forward 3. Okay, and then this one here, plus 2. And then I go down 3, forward 2. So they are going to cross, okay? They're not parallel because the slopes aren't the same. But when they do cross, that's a crappy line I drew. That isn't, they are supposed to cross at a 90-degree. Okay, now, in order to do what you're going to do today, you're not graphing. You need to know how to find a reciprocal of a number and how to make it opposite. First off, you have to have a fraction in the first place. If it's a whole number, you put a 1. Then you turn it upside down. And if that's positive, I want negative here. Flip it. If that's positive, we need negative on what we're doing today. You can leave that, but you got to turn it upside down. That's positive. I need negative. Flip it. That's positive. I need negative. You're just practicing a skill. Flip it. That's negative. I need positive. Okay. Flip it. 6 over 1. That's positive. I need negative. Flip it. 1 over 6. That's negative. I need positive. Flip it. That's positive. I need negative. Okay, now we're going to start the examples. I got 6 of them. Okay. Write an equation in slope-intercept form. By the way, write an equation in slope-intercept form just means this, okay? Passing through the given point and perpendicular to the given equation. Now, just like when they talk about parallel, perpendicular, you wall the y, you put an m, you ditch your b. But here's the main difference. You don't use the same m. That's what you do if it's parallel. What you need to do with the m on perpendicular is make it a fraction. Then you need to flip the fraction to 1 over 3. And then you have to ask yourself, right there, is that negative or positive? It's negative. So I need mine to be positive. Okay. Now you do everything the same. 1/3 is your m. That's your slope. Okay. And b is y equals m times x plus b. And your m is the 1/3 that we got. Okay. 1/3. Then x and y comes from the coordinate solution because that's a solution to this line. So I put 2 in for y. I take 1/3 times -6. So 2. Go to a calculator, take 1 ABC3 times -6, you get -2. Plus b. Plus 1 dot b, so the wall goes up and I add 2. 2 plus 2 is 4. Divide by 1 would still be 4. So that's your answer. These two equations would have been perpendicular. Okay. Next problem. Perpendicular to y equals 1/2 x minus 1 through -2, 3. So whenever they mention parallel or perpendicular, you wall the y. The y's got to be by itself, so you can put m and b labels, a slope and y-intercept. But you don't want that b. You quick get rid of it. Okay, then same setup, but our m will not be the same because perpendicular lines are not parallel. They do cross. Flip that to 2 over 1. Okay. And that's positive. So over here we need this to be negative. And also if you have a 1 under it, you can just call it -2. You can put -2 over 1. It'll work, but so forth. And then b, y equals m dot x plus b. So m is -2, and the y and the x come from here. So y is 3, and the x is going to be -2. -2 times -2 is 4 plus b. Okay, so I have -4, -4, 3 minus 4 is -1, you got 1 dot b. You can divide by 1, but it's still just going to be -1, okay? And these two are parallel, okay? Did I do that right? Yeah, I guess I did. Okay, it's fishy looking. Okay, again, perpendicular. Perpendicular parallel, first thing's that. Wall to y, MB. Okay, get rid of your b. With parallel perpendicular, you don't want to use the b they gave you. You have to find a completely different b. Okay, so the m, again, you don't use the same m either. It's not, you do that with parallel. With the m, you have to flip it. So you make a 1, so you can flip it, and you flip it to 1/5. Now, if that's positive, then ours needs to be negative. So again, with perpendicular, you don't use the same m. You need to flip it and change the and make it opposite. The opposite of positive is negative, okay? So B, y equals m times x plus b. So the m is negative 1/5. And for x and y, as normal, we put 3 in for y and then 10 in for x. So I go negative 1, ABC 5 times 10, it's going to be negative 2 plus b. So you add 2, 3 plus 2 is 5. All right, next one. Okay, now, ooh, you got some work to do. You can't put an MB label till that y is by itself. Okay, so you remember how to do that? If not, that's what we're going to do right here. Okay, so I can't even think about coming over here till I isolate the y, and I've taught you how to do that. Okay, so first off, put the 1 there, plus negative, dot and circle your y. We never want that to be a negative number. Okay. So we're going to make it positive, and then the outer two go opposite, and then we have to get rid of that negative 1x by either adding or subtracting. We're going to add 1x, but then I need to create a 0x so I have a place to add 1x on the other side of the equation. Okay, so I line up my equals. On this side we got 2 dot y. That's going to be 1x plus negative 4. Now just divide everything by 2. And we have it 1 divided by 2 is a decimal, so just leave it as 1x over 2. And that's going to be minus 2. So MB now, ditch your B just like you would at its beginning. Then 1 over 2 has to be flipped on a perpendicular problem to 2 over 1. And if this is positive, then we need to make this negative. Now negative 2 over 1, you can just use negative 2 if there's a 1 on the bottom. And then b, y equals m times x plus b. Okay, so the m is negative 2. The y and x is still coming from the 1, negative 6. So negative 6 times 1. Negative 2 times 1 is negative 2 plus b. Wall goes up. So add a 2 to both sides. That's negative 4. Divide by 1. Negative 4 divided by 1 is negative 4. Okay, I'm going to go with 2 more. I don't think I was mean on the assignment. I think the y's are all isolated. I didn't think you're going to have to rewrite it. Perpendicular to y equals 1/5 x plus 3 through 10 negative 3. Okay, so wall to y. It's by itself, so you have your m, you got your b, but with parallel perpendicular, we have to come up with our own b. We're also going to switch the m on perpendicular. Parallel we use, if it said parallel instead of perpendicular like it did last Friday, I would be using 1/5, quick writing it down. But it doesn't. Now here's my first question. Is that positive 1/5 or negative 1/5? It's positive, so you need to make yours negative. Whatever it is up here, yours goes to the opposite. And you need to flip it. 1/5 would flip to 5 over 1. Now, if it has a 1 on the bottom, you can just use negative 5. And then b is the same as it's always been. Y equals m times x plus b. So, your m is negative 5. Your y and x come from this coordinate. So, negative 3 is your y. 10 is your x. This is going to be a huge answer here. Okay. So I take negative 5 times negative 10, that's negative 50 plus b. Remember, 1 dot, you should be getting used to solving for the b here, finding the y-intercept. So I add 50 Add 50. Negative 3 plus 50 is 47. And you can divide by 1, or you can just get rid of the 1 because it would stay at 47. Man, glad I don't have to graph that. That'd be hard. Not hard, just you'd have to have a huge graph to get all the way up to 47 so you can go down 5 over 1. Okay, perpendicular to y equals 2/5 x plus 3. Okay, perpendicular wall that, m that, b that, but get rid of your b. Okay. Now, perpendicular, I can't write down 2/5. That's on parallel where I use the same m. Perpendicular, first off, you have to switch the sign on this. 2/5 is positive, so I need negative here. Also, I need to flip the ratio, 5 over 2. So negative 5 over 2. So B. So negative 5 over 2. So 5 for y times negative 6. So I go negative 5, ABC 2 times negative 6, that's 15. Wall goes up, minus 15, minus 15. 5 minus 15 is negative 10, 1 dot B. It's going to be negative 10, okay? Let me know if you have a question about how to do your M. We'll talk about it. Okay.